Hi, welcome back. So in this video, we are going to discuss how to calculate p-value for the right-tailed t-student test. So first of all, in the context of the right-tailed t-test, p-value is interpreted as probability that value computed based on the sample data, tt, is smaller than the critical value of t. So as you remember, for the right-tailed test, we reject the null hypothesis if and only if the value we computed goes within the rejection region. So it's bigger than the critical value. Here we are seeking for the complementary probability. So obviously smaller p-value is more desirable for us because it is associated with the higher degree of certainty associated with rejecting the null hypothesis. So let us consider the following problem. It should be familiar for you. In the previous lecture, we tested whether the mean score for the first player and for the second player as well is bigger than 0, and we used the method of rejection regions. So here we are going to do something different, but of course conclusions are going to be pretty identical. Okay, so as we did before, we have to compute t statistic for the first and the second player. And we do this based on the value of sample means and sample standard deviations. And when we used the method of rejection regions, we had to assume some value of alpha, and then we had to look for the critical value of t associated with the assumed value of alpha and the number of degrees of freedom. Now we are going to do something opposite, which means that we will investigate which value of alpha is associated with t statistics we calculated based on empirical data. So we are going to investigate this table. And again, we are looking for the closest t values. Of course, it is possible to compute the precise p-value using Gretel, as we will discuss later at the very end of this lecture, but actually you will never manage to find a table that large that it can actually contain all the possible significance levels. So that's why we are seeking for the closest value, and just to stay safe, we are looking for the lower value. So for instance, for the second player, t statistics was 0.81, and we still have 8 degrees of freedom because we have 9 observations for each player. So I can pick either this one or this one, but this one is actually bigger than the value I have calculated. So that's why, just to stay on the safe side, I would pick the lower value. And here the respective value of alpha for one-tailed test is 0.25. So this means that I can reject the null hypothesis only at 25% significance level, which is not enough. So as we discussed in the previous video, there are 3 conventional levels of statistical significance: 5%, 10%, and 1%, of course. Yeah, I did not manage to preserve the right sequence, but you still see the idea. So typically, if you find p-value which is bigger than 10%, you just say that you failed to reject the null hypothesis even at 10% level of significance. So for the second player, we definitely cannot reject the null hypothesis. And when it comes to the first player, then t statistic we calculated was 3.99. So again, I can pick either this one or this one, but just to stay on the safe side, I pick the lower one. And for one-tail test, the corresponding value of alpha is 0.005, which is less than 0.01. So I can conclude that for the first player, the null hypothesis can be rejected at 1% significance level. So that's it. Basically, yeah, just to make a conclusion, when it comes to the first player, we can reject the null hypothesis at 1% level of significance because p-value we extracted from the table is lower than 0.01, and in case of the second player, we cannot reject the null hypothesis even at 10% significance level because p-value is bigger than 0.1. So that was it when it comes to the right tail test, and thank you for your attention.